Welcome to the presentation of investigating usability and user experience of individually verifiable internet voting schemes. I am Karola Marky. I am from the University of Glasgow, and let's start with a simplified overview of online voting. Let's assume our voter here wants to vote for their favorite color, which is green. They use a voting software to mark a ballot, and the voting software then generates an encrypted vote that is sent over the internet to a ballot box server. There it is stored until the end of the election, and then the authorities tally all votes and announce the result. Unfortunately, there are a few things that might go wrong here. There might be malware on the voter's computer, changing the choice from green to red. There might be some kind of interference during transmission, or the votes on the server might be manipulated, just to give you a few examples. And because of that, the integrity of our election results is in danger. But let's assume for a second the world would be a peaceful place and everything would be all right. Even then, there might be some problems based on the technology used. There might be simply some bugs in the voting software, there might be some transmission issues. So the infrastructure also impacts integrity here. And such issues are really difficult to detect because only the voters themselves know how they voted based on voter privacy. So to overcome these issues, the research community proposed the concept of individual verifiability to allow voters inspecting the cast votes to see if they match their intention. If not, we can detect such issues. They can trigger an alarm and authorities can investigate. But for that, we need to make sure that voters are indeed able to verify their votes without having any special expert knowledge. So to investigate human factors of individually verifiable internet voting, we did a structured literature search where we identified 34 protocols in the scientific literature. We clustered them into 4 categories based on voter actions, meaning the tasks that voters have to do to verify successfully. But we also considered the timing within the electoral process. The first category is called audit or cast. It means before vote casting, but after the ballot was marked, the voter decides, am I going to verify this vote or am I going to cast it? So it is a probabilistic scheme and verified votes cannot be cast here. The second category is called code sheets. During vote casting, the vote is sent to the ballot box. The ballot box answers with a verification code. Now the voter needs to inspect this verification code and compare it to data that they received before the election on a trusted channel. If this verification code belongs to the candidate they wanted to vote for, we know everything is all right and the vote can be cast. This has been used in officially binding elections in Switzerland. The third category is called verification device. This is done after vote casting. We use a second device, for instance a smartphone, to download the vote from the electronic ballot box and reveal its contents and see if they match our intention. This has been used in Estonia for quite a while. The last category we denoted as tracking data. This is done after vote tallying, so after the results has been announced. The results are announced together with a list of clear text votes and so-called trackers. Each voter has an individual tracker and they can use it to identify their vote. So here our tracker is 1337 like earlier, and we know that this is our green vote, so everything is all right. As I said earlier, it is quite challenging to delegate or automate this process, but there's also a protocol for delegation based on zero-knowledge proofs. However, this fundamentally changes the way voters have to vote. So in our investigation, we decided to investigate the 4 main categories in a user study with 100 participants. We briefed the participants first and presented them with the voting materials that we created inspired by the last federal election in Germany to provide a realistic scenario. Then the participants were allocated to one of the 4 groups and cast 2 votes. The first one was a normal vote, consider it like the typical case, like you would expect to be in an election. The second vote was a manipulated vote, so we simulated an attack and we wanted to see if participants are going to tell us about that. Between those 2 interactions, we gave them the user experience and the SOS questionnaire. After the second run, we also give them another final questionnaire to investigate their perceptions. So we obtained the usability metrics in terms of detection rate for effectiveness, completion rates for efficiency, and SOS scores for satisfaction. We also measured the user experience scale with the user experience questionnaire, received trust and understandability. We used our data to identify points of failure and misconceptions, and finally provide final recommendations. And in this talk, I will present you an excerpt of that. So let's talk about the detection rate first. The chi-square test revealed significant differences here. For the post-hoc test, we looked at the adjusted residuals and applied Bonferroni correction, revealing that code sheets and audit or cast have an effect on the detection rate. You see that audit or cast has an alarmingly low detection rate of just 28%, while code sheets have the perfect detection rate. This, however, comes at the expense of efficiency. So here you can see that when interacting with code sheets, participants needed significantly longer compared to any other class of voting schemes. It took them approximately 10 minutes to cast and verify their vote. Another part of our results considers here understandability. Here we clustered participants in no understanding, partial understanding, and complete understanding. What you can see here on the right is that even if everyone verified successfully using code sheets, there's still some understandability issues. On the other hand, about half of the participants who verified using audit or cast had not a clue what they are doing, and this is really alarming. So let me conclude with an excerpt of our final recommendations. First, something that is quite important is you should consider vote privacy aspects. Recall that when using tracking data, you see the clear text list of all votes with an individual tracker. Participants were really fearing that this might interfere with their vote privacy, which in the protocol is not designed, so it's designed to be private, but here participants didn't consider it that way. We also thought it's really important to verify the cast vote. In audit or cast, this is not the case, and participants considered it to be redundant and wouldn't use verification at all. Code sheets were the only set of schemes where verification was mandatory, so we had the perfect detection rate. So authorities should consider the impact of mandatory verification. And finally, it is important to consider the timing of verification, because participants here also feared that they might forget it if the result is announced 2 weeks after the election, or if it might be too early before vote casting, they might again consider it to be redundant. Of course, there are more results in the paper. And with that, I would like to conclude my talk and say thank you for your attention. Bye.